So, guys, look at me first. Today's date is the 27th of February 2026. The time now is 9:18 a.m. So I want to vote again. What's going to put for OBNXS, my business, human installation. But this is basically on NSIGII firmware, controller, which operates on the NSIGII firmware, November, SSR, Alpha Indigo, Chief Code, Alpha India, firmware, which operates on controller, controlling. But I'm trying to have this is basically the reverse Turing test, reverse Turing, inverse relay and replace system for reverse Turing test. Gonna watch a video now, but gonna how to install a machine and how it works. We're trying to construct an arbitrary machine called the reverse Turing system that works backwards. So we're gonna work backwards and because backwards computation via measurement factor of a pictogram model. So we're gonna take a look at the picture. So you're gonna get to how it works basically. In layman's terms, I'm trying to guys take a machine state, a valid state of a machine, a full machine, which is called a snapshot of a machine. And I'm gonna get my pen. I'm gonna try and draw it now. So I don't use text tracker, but some kind of machine. That let's say a football machine. But my one was in time, so my one was a football machine. But my machine is a Trident trouble. For machine. So I'm just get a machine, a valid Trident state, and encode it as some kind of firmware system for control, and controlling for micro OS, M for Mike, U for kilo of Oscar. But the main objective is to have see whether a system can replace itself by observer. So the observer is basically 2 reads, 4 writes, allowed for 1 observer. Let me start the board to do this now. You're gonna have oh god, you know what happens? You're gonna have fucking 2 reads, 4 writes. Like so, which is basically a read, 1 read. 1 read which will 1 can't read. That was saying I believe the writer basically will say yeah. Read right. Read right. Slowly sound. And then I have students clearly. We have so trying to do this basically formally. So we're gonna have 2 reads and 4 writes per 1 read operation. So there's no execution here, there's no execution model. But it's usually used by measurement, it's a measurement tool. 2 reads and 4 write operations for 1 thing. This is going to have a void pointer, 2, 3 things. Token memory, the memory section behind, token type, and token value, You have 3 pointers system. These are 3 triangle pointers to 1 thing called 2 reads or 1 writes. So this basically, if you have 2 operations, 2 reads operation, and 2 reads or 4 writes, that means you have it in calculable so that means the inverse is true, which would be 4 write and 2 reads. Yeah, 4 write and 4. To write something, you have to have 4 reads, and 2 writes. Basically, you're gonna invert it because you're now writing. So that's really there. So we're gonna go this one over here. So this is my measure two. So this is a vector. The vector has a scale. So you can have a bigger vector. So but this is one measure of the system. Now that system is a mass. You're gonna have like 4 reads. Say we have a service segment that 512 bytes long. 512 byte long and contains message. Message. Please help me. Please help me. Please help me. But this is basically an operation. So this is an hexadecimal. You don't know it's a hexadecimal, but it's going to be called the hexadecimal. So this is a kernel. So this is just a reader writer, but this is the inverse reference. This is the ability machine for a system of non-reality. So we're gonna have please help me there. So 402 bytes allocated to this message here. Let's say you have a system origin so this measure. So you're gonna have the computation of a half. So you're gonna have the 4 states, you're gonna have everything in twos. Like you're gonna have one half, 1/4, 1/6, 1/8. These are 4 bytes of memory segmentation, but they are one divided by 8, 1 divided by 10. So you get 1 feeling. So you're gonna have everything in half. So it's called a conjugate model of binary system. So these are called the conjugate model. So these are called this system. 1, 2, 3, 4, 5, 1/10, 1/12, 1, 2, 3, 4, 5, 6. 1/14, 1/16, 1, 2, 3, 4, 5, 6, 7, 8. So you're gonna have 0, 0. I'm gonna have 0. For example, if the message is so if the byte is say you get the number. Let's say you get the number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. If you have the number 0, 0, 1, 1, 0, 1, 0, 1, 0, that's basically by default. So 1/2 would be 1 divided by 2 would be 0.5. So 0.5 plus 1 divided by 6, which would be 0.7 plus 1 divided by 10. 1 divided by 10 is 0.8 plus 1 divided by 12 is 0.9. So this number is 0.9. 0.9. 1, 2, 3, 4, 5, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So, and so you got basically, you got 16, you got have 16, 1, 2, so you got 0.9 here, 0.9 equals 0.9 equals 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0. And one thing to you is, that number is binary. It's basically not 0.9 in 16 ones or 1 to 16. 1 divided by 16, which is 8 bits. 8 bits conjugate number. So basically, this number is even. So the total number you can have if we are 0.9 divided by how many more of the system. So in other words, 0.9 divided by so the maximum number we can have 0.9 is 1 divided by 16, which is 0.1. 0.1, which is the minimum. But this is 0.1. You can have 0.16 plus 1 divided by 12 plus 1 divided by 14 plus 1 divided by 10 plus 1 divided by 8 plus 1 divided by 6 plus 1 divided by 4 plus 1 divided by 2 is 1.4. Now, 1.4 is the maximum you get in the system. 1.5, 1.5, 1.4. So you can have the 1.4 maximum. So the total number divided by how many there are. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8. That is 0.2 at average. So you have to go, so 0.2. So this can go to meaningless now because you get 1.4 divided by 0.2. Well, so you're gonna have a measurement. But is it the average of the family? You're gonna have the type average of suggestions. You're gonna have some shift here. So what I'm saying is, you have a Turing machine, and some machine has a read right, but this is a scalar. This vector is a scalar. 4 read and 4 write and 4 4 write. 4 read from 4 read up to 2 write to 4 write. But this is basically the memory allocation for the system. 2 reads and 4 writes. You're gonna have 4 reads and 2 writes. We're gonna have the opposite. So this is for a right version. For right version. No. Opposite way. So opposite way. Sorry. You're gonna have just to form 4 reads. So that's to form a real version. That's to form real version. Before so it's all the way to 7. How many mistake, guys? So for mistake, you have to form 4 because you have to do an order. This is an order. You have to do opposite. So this was the read operation. This is the read here. Sorry, guys, this is the read here. I'm pretty sure. This is the read here. Well, this is the right here. 4 reads and 2 writes. And this is read here. Will really be 4 reads and 2 writes. 4 writes and then 2 reads. 2 reads operation. If you look at it in half, so you see that the model here, because when you're going to see that some. What I'm saying to you is here, let me share my screen. We're gonna look at this video on the Turing test and see what happens. So this is how the Turing machine work here. So let's watch this video. Look at question or so data proving system, my proving systems. I'm so proud. So I'm saying to you, doesn't say. So that was it. So basically that's Turing complete. So it takes so you have a data, a state, I'm just going to process them this time. So I'm trying to take a measurement of an algorithm system. This is called a profiler. So this is a single firmware and a profiler. So he's gonna look at the program. Does it do what it needs to do? But the profiler is called a profiler, just like a in-memory profiler. So so this one is that. So if you think about it more literally sense, I'm trying to take the Turing machine and going to look at a profiler. Now, this is basically a profile for your program, not the human beings, the program. The program, if you have a test, test suite, we don't need test suite now, but if you have a test suite, does the program do what it needs to do? Yes. But does the inverse relay system agree that it needs to do what it needs to do? It's a disjoint symbiotic contract between the program and the system itself at fault, So but basically, so you're gonna have a read write head on the tape, and you're gonna have a final control, you're gonna have a read write head, but the so you're gonna have you're gonna have an initial state, uh, B is also blank, X and Y markers of step. But you're gonna have a pictorial model of it. So this is a transition table. Now the transition table is one pictorial model of the state. But, according to the pictogram, because it's a table, you can observe information from. But it's a transition table. At the end of the day, it's a transition table. So you have different organization for the system, but the system is basically as complete as a computer. So it's basically as a Turing machine. So you have different models of insights you can get. You call it a model because it's a pictogram of a system. So I'm trying to take a starter machine, do the final control and the head, A to A, N, and B. Recreate and take a tape. So it says here, A is the final set of Q symbols. One, A, an input symbol, signal. It take alphabet gamma that includes sigma, a transition symbol, delta. This is delta or Q alphabet. And a state symbol Q. This is Greek alphabet in order. Yeah, this is delta. So gamma, delta, epsilon, zeta, alpha, beta, alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, So you're gonna have the delta alphabet and start symbol Q0. Now, a blank stick will be or sub B and the first symbol is so that the blank symbol. So you're gonna read and write to this system. Here B, you gotta move from left to right and move from left to right. So it's going to so so this is basically a program profiler that's shippable, but it works by literally looking at the kind of state transition and having a read write file. Basically, gonna upload read write file of some to status quo. Like you do you do integration testing or not? I love that of this. You can show me the result of this. I mean, the health of the program. It's like the health of the program. So the single firmware really evaluate the health of the system before it's as it's running in real time. So it doesn't matter what you read or write to the tape. Gonna have a system of the before of the after because the system provides the little codec of the state of the system as it runs, as it runs. So I'm thinking of it kind of counterintuitively, but because it's an inverse one, so it's basically taking the measurement of the system and get working really. So inverse means definition. Inverse means it holds the state. It holds the state of the system accountable that is not its own, but it has a relay mechanics. So the relay mechanics is a replay system. So you can relay something. But so if you have the message I need help now, you can relay it two ways. You can have the message I need help now. I need help now. Now help need I. That's one way to do it. Now help need I. Or you can have it backwards, fully. But as long as the message is there, as long as the tokens are represented in the way that now help me now, so help I need help now. Now help I need I. Or like or something like the replay. So the replay will be in time. So it will be time. Let's say the time is psi, time is delta, and delta t of time basically represents time. So that'll be for every second of the message you do. So that's the to do. So I'm trying to have a profiler. The profiler will be what the machine does over read or write, but no execution. So the profile will give you the state of a program. The program is NSIGII, but it will not give you any execution flags. Will not give you any execution flags. For example, here we have this one. So let's see how terminal 001 and underneath the 0 B, the movement moves from to instruction Q0 to equals Q1. X and execute. So goes to state 0, replace 0 by X. And move to here. So if it stays 0, Q1 is 0. So the movement moves on Q0, so represents 0M. For what is called a grammar. So this moves 1. C to 0 means remain the same state, not changing the symbol. But it's a 1, so it's trying to eliminate all zeros. So basically, it's going to name BXXR. So basically, it takes so you're gonna have a statement of here. So in another machine, this can be more than one possible state. So you're gonna have some stuff. That's logic. So you're gonna be one. This is through competition machine. So guys, thank you for the Turing machine. It's a term. This is jumping hierarchy. So you're gonna have times 0 this is the calculation. So you're gonna have obviously grammar times 0 grammar. But you're gonna have things that times 0, which is just natural grammar language, but that's times 0. So you're gonna have the magnitude of less than b equals to d. But this is using for ref. So this is times 0. So I'm gonna pause it now. No grammar or right. So you're gonna have a terminal. So you're gonna have So thank you. This is for Rift as well. Thank you guys for watching the video. For that goal of the video, I didn't really do any math because there's too much here. But I'm just demonstrating like because I have some things replayable from a grammar system. So my machine. So if the machine starts with BXXYY, because there's no codec. There's no codec. There's no codec. We don't know what the codec is. We can work at this codec by deciphering what it should be, and code will be 00001 B. For any language in the world that's made up, for the kind of a profiler. So the profiler takes a program, and that profiler file is gonna have the app of a profiler, but it's gonna be the profiler of the message itself. It's gonna have two NFL resolutions of the system. This one have what's code. It's gonna be free of charge. Thank you guys for watching this video. So I'm coding and decoding. I don't really think I do more watch today, but okay. Thank you guys for watching this video.